Lecture number 3, right? Computer Science 350. Today's Tuesday. Okay, let's go. By the way, on Thursday we're going to have a quiz, right? It's going to be Blackboard based, everything open, online, everything which was mentioned somehow during this lecture and the previous lecture is a fair game for the quiz. And you'll be timed. You're going to have like 10, 12, 15 minutes. Yeah, but I guess you know the routine. Okay, cool. Lecture number 3, let's continue talking about what we talked about last time. So we finished up with saying that empty string is basically string which contains no symbols, right? Nothing in it. And the length of empty string, so basically how many symbols do we have in an empty string? 0, right? So because that empty string contains nothing. So the length of nothing is 0. Okay. Moving on. Reverse. Reverse of a string is the string written the opposite order, right? So if you have, I don't know, like a race car, then in this case, what was the reverse of that? Reverse of that would be race car. Exactly the same thing, right? Okay, substring. Substring of a string W, right? So let's say we have a string W. Substring of that string, of the string W, is a sequence of symbols Z, okay, which appears in W, okay? So substring of a string W, or sometimes it's called omega, is sequence of symbols, Z, right, which appears in W. So basically, if you have Z concatenated with some amount of symbols, you get W, okay? Now, any string is a substring of itself, okay? So if I have a, let's say, a string called a race, right? And I'm gonna ask you, like, let's say race car. If I have a string called race car, right? And I'm asking you, is race car a substring of race car? The answer is yes. Any string is a substring to itself, right? So the question is, empty string, is that a substring? Hold on. Empty string, is that a substring of itself, right? I'm not even sure, honestly. Sequence. Technically, yes. I think yes. But I can't be sure about that. Okay. Let's. Yeah. Let's get to another definition. Okay, so lexicographical order is an ordering of strings as it would appear in the dictionary. So basically alphabetical order, right? Now prefix. What is a prefix? What is a prefix? What is a prefix? So prefix X of a string Y exists if a string Z exists where XZ is equal to Y. Okay, so prefix X is considered to be prefix of Y, kind of if and only if there is a string Z which, if you concatenate it with X, it gives you Y. Okay, so that's a formal definition of a prefix. I know, like it's a mathematical, you know, it's like very short, very concise, super difficult to understand. It's definitely not like a human readable language, but yes, that's a formal definition of a prefix. Okay, so basically, if I'm giving you a string, let's say Y, and I'm giving you a string X, right? I'm asking you, like, is X prefix of Y? Okay, so kind of the way you should be thinking is that does there exist string Z which, if you concatenate with X, will give you Y? Moving on. Proper prefix. Proper prefix is defined as x, which is not equal to y, right? And then we need to use this symbol. Where's that symbol not equal to? This guy over here. Okay, so proper prefix is defined as x, which is not equal to y. Okay. So, or in other words, right? Said another way, modular of z is not equal to 0, or z is not equal to empty string. Z is not equal to empty string. Okay, so what's the difference between prefix and proper prefix? Okay, so any string can be prefixed to itself, but any string is not a proper prefix to itself. So a proper prefix is defined basically the same thing, right? So prefix x over string y when those two things are different from each other. So for example, if I have a string race car, right, and I'm asking you, is a race car a prefix of race car? The answer is yes, right? It's possible. Why? Because again, like according to this definition, prefix x over string y exists if the string z exists where z is equal to y. So if I'm asking you, is a race car is a prefix to race car, you would say yes, because x would be race car, which is the prefix, and then z would be nothing, empty string, and that gives us equals race car, which is the final string. However, when we're talking about proper prefix, it's important that z would not be empty string. So z has to be different from empty string. In this case, any string is not a proper prefix to itself. Okay. Next, language. Have you guys thought about what language is? Probably not. And now it's time to discover finally what a language is. So language is a set of strings. Okay. So basically set, we'll talk about that, strings, right? So like you put those strings under one hood, that's called a language. Language is a set of strings. Now, prefix-free language. Okay, what is that? You're probably curious to know. That is a language. Language where no member is a proper prefix to another member. Okay. So prefix-free language, I think that there should be hyphen. Prefix-free language is a language where no member is a proper prefix to another member. So again, language is a set of strings, right? And you can technically kind of find one string and prove that it is a proper string of some other string, right, in that language. And then if it is possible to do, then in that case, this language will not be prefix-free. Okay. If it's possible to do, if it's possible to find two strings, right, where one string would be proper prefix for another string, in that case, that language would be. So yes, if it's impossible, then prefix-free. If it's possible, then it's not prefix-free. So the question is, for example, English language, is that a prefix-free language? Yes, no? No, yes? What do you think? Comment down below. I'm joking. No. Of course, it will not be prefix-free, right? Because it's possible to find two strings, which would one of them which would be proper prefix of another one. For example, Spider-Man, right? So in English language, I can find Spider-Man and spider. So spider is a proper prefix of Spider-Man. That's why English language is not a prefix-free language. Moving on. Function. Function or mapping. Okay. So that's probably what you guys learned in discrete math. Okay, so it is an object that sets up a deterministic input-output relationship. Okay, input-output relationship. So basically f of A is equal to B. Okay. Moving on. Domain. Domain is a set of possible inputs. Okay. So basically, like this A, right? This A is an input and B is an output. So set of all possible A's that would be the domain, right? And then the opposite of that would be range, right? Range. What is that? That is a set of outputs mapped from inputs. That would be called the domain. Okay. Now, in terms of the notation, okay, so we basically say given a domain D, now range R, and function f is spelled the following way: f colon D arrow R. Okay, so basically a function which maps a member of D to a member of R. Okay, well, in other words, to make it simpler, right? To make it simpler. Okay, so let's say we have two circles, right? One of them is called D, the other one is called R. D, R, okay. So, and let's say both of those sets contain some natural numbers, right? So a function would be, so a function is something which maps any element from D to any element of R, okay? So for example, there is an element 0, right? And there is an element, let's say 1, okay? So a function which would be some kind of like, well, we use the mathematical expression, but it's not necessarily has to be the way. But it would map 0 to 1 like this. Okay. So basically, not sure if you remember the hash function from the previous course from 318, right? You basically given the input to that function and it spits out the output. Okay. So you're given that 0 and it gives you 1. Okay. So that is a function, and on the left you have that set which is called the main. That's where the input comes from, and on the right you have the region where the output are located, right? These two sets, they don't necessarily have to look that way. They can be exactly the same set, right? It's possible. They can be two different sets. They can have intersection, right? So they can have some kind of overlap. Yeah, it's possible that, for example, the range R is nothing, empty set. It's also possible that the range D is also empty set. In this case, kind of the whole thing kind of becomes not valid. It's useless. Yeah, for example, I can create a function, right? F, which would be, I don't know, y equals x times x, right? So x squared, basically. Okay, so in this case, what is D? D is like all the numbers. What is range, right? A range would not be all the numbers, because, for example, if you have negative numbers, if you multiply them by themselves, they become positive, right? So the D, the domain, can be like, in that case, D would be everything, right? It will go from negative infinity to positive infinity, okay? But the range, though, will go from 0 up until a positive infinity, okay? Because again, there is no way you can multiply a number by itself and then get a negative number. It's impossible. Okay, so you need to keep in mind these two different things. So in this case, again, if I kind of try to draw these guys. So let's say if that is our D, right? If all numbers in the world are located in this set, right? then only half of it, so it'll be like this, right? Only half of it, only half of it would be R, right? Because it'll go from 0 to infinity. Cool, hope it makes sense. So that is the formal definition of function. Now let's talk about function table. So saying y is equal to x squared is one way of defining a function. It's also possible to have function table, okay? What is that? It's basically kind of, if I say f colon and then I provide a set, right, of the main, so -2, -1, 0, 1, 2, right? And that all has been mapped to, let's say, n, natural numbers, right? In this case, so like here I defined my domain, my region, right? Now we need to define the rule of how we map elements from the main to elements of the region. And we can basically create a table for that. Let's say insert table. We need something like this. 6, okay, 6. Okay, so it's going to be x, and that's going to be f of x. So here we have 0, -1, -2, and then 1, h, 2, okay. And then f of x, let's say, maps to 0, 1, let's say 4, 1, 4, okay. So that's another way of defining the function. Basically, just take all the elements from one set, map them to some elements from the domain, from the region, right? And basically describe that in the form of a table. So you can kind of guess what the function is, what kind of function is behind that. It's also x squared, right? But maybe I'll say, I don't know, like 1.5, right? In this case, it's not going to be a squared anymore. What is it? Nobody knows. There's probably no way to describe it mathematically. But it's still valid. It's still possible to do. So a couple of properties of a function, right? So let's say you have two sets, right? And you just, whatever element you take from one set, you can map it to, function is going to map it to an element from another set. So number one, that needs to be not changing in time. So let's say 100 years ago, I mapped 0 to 0, right? I created a function which maps 0 to 0. In this case, 100 years from now, and now it should not change. Okay, that's number one. Number two, it's possible that you have two elements in the domain which are mapped to the same element in the region, right? But the opposite isn't possible. You cannot have one element in the domain which should be mapped to two elements in the region. That's impossible. That is not a function anymore. Okay. Hope it makes sense. Moving on. Okay, finite automata. That's something which will. Okay, so we're going to introduce it now, and then we're going to reintroduce it again. So, but anyway, finite automaton. Okay, so yeah, finite automaton, which means it's only one, right? So that it's a really weird word, but a singular from that word would be automaton. Finite automaton is a 5-tuple. Okay, what does it mean? It means it's a sequence of 5 things, 5 sets, 5 elements. Okay, 5-tuple. Okay, what are they? Q, the first one. Then the next one is sigma. Insert special character. Sigma. Okay, so Q, sigma, then delta, small delta, also special character, H, that's what it looks like, delta, and then Q0, Q with a subscript of 0, and F, so that needs to be this way. Okay, perfect. So 5-tuple, that means there are 5 elements, Q, sigma, delta, Q0, F. Okay, where Okay, now let's try to kind of guess what they are. So Q, you're probably not gonna guess that. It is a finite set called states. Okay, and then we're going to discuss what does it mean to have a state. Okay, now then sigma. Okay, can you guess what sigma is? Sigma is the alphabet, is a finite set called alphabet. Okay, then delta. Let's talk about the delta first. Sorry, last. Then we have Q. Okay, so what is Q? Okay, Q is state which belongs to capital Q called start state. Okay, and then final. So the F, finally F. F would be a subset of Q, right? So basically F, Q, and then we need to use this symbol which does subset like this. H. Okay, so F is a subset of Q, so this symbol means subset of Q, right? Called set of accepting states. Okay, keep in mind that we didn't say, well, it's a subset, right? And the Q is finite, so which means F is also finite, but F is a subset of Q. Does that mean that it's possible that F is empty? Yes, the answer is yes. It's possible that F is empty, which means there are no accepting states. Q though has to exist. Q, it is a state, right? So it's one state, only one single state. And now let's talk about delta. So delta is going to be transition function. Transition function, okay? And here's how we define that. Remember, right? So we write this column, right? And then we need to specify the domain and then arrow and then the region. So the domain would be what? Domain would be our alphabet, right? And the region would be Q. Okay, transition function. You probably understand zero of what I just said, and it's totally fine. We'll get back to this definition, and I'll actually like explain that like a couple of more times. Just memorize this for now, and that's it. Once you get ahead of it, once we will be solving the problems with finite automaton, FAs so-called, it'll be a lot of fun. Okay, but I understand that as of now it probably makes no sense. Okay, moving on. Set formers. Okay, so how we describe sets in maths. Let's talk about that. So set former is an expression of the form. Okay, so here's what it looks like. You have braces, okay, then you have expression, some kind of expression, okay. So those angular brackets, that means like you need to put your expression there, and then you have the vertical bar, okay, which is usually read as such as, right, and then you have some kind of property, okay. Here expression is some arbitrary expression, usually involving one or more variable names. Okay. Example gratia, x, y, z. Okay. And property. Is some statement about the variables used in the expression. Okay. The divider can be read as such as, or such that, sorry, such that. And the set former itself can be read as, okay, and that's a kind of a definition, but the word, the verbiage you need to remember. The set of all, okay, so you basically always say the set of all, and then you provide a verbal explanation of expression. So this, the set of all expression such that property. Okay. That probably doesn't always mean much, but let's get to examples. Okay, so I'm gonna give you an example of a set former. Okay, I'm gonna say belongs to, but in your notes, please do this symbol when an element belongs to something. Belongs to. Okay. So what does that mean? Hold on. Superscript. Really weird. Okay, I'm going to do times x. Okay, perfect. So there is a set that, which is created using a set former. Okay, how should it be read? That is, okay, you should read it as the set of all x, right? X squared, where x such that x belongs to natural numbers. Okay, so in other words, you can say that that is a set of x squared where x is a natural number, or such that x is a natural number. Okay, so that's usually how it's read. It's a very simple example. For this particular example, you can basically say it's a set of all set of squares for all natural numbers. You can say that as well. Totally cool. Yeah. Moving on, another example. So basically the same thing, but belongs to z, and 1 is less than or equal to x, and x is less than or equal to 5. Okay, basically the same thing. So it's a set of x squared. It's a set of all x squared, such that x belongs to z, and x is less than greater than 1 or equal to, and x is less than or equal to 5. So that's how you should read it. Okay. So we can say that informally, this is the set of all squares of integers in the range of 1 to 5, inclusive. Okay. Perfect. Okay. It's very important that x is considered to be a dummy variable. Okay, dummy. And the question is, what does dummy mean, right? Let me give you, I guess, a formal definition of it. Okay, so which is used in a set former and has no meaning outside of the set former. Okay, so in other words, over here, that basically again means like this set, right? It's basically the set of all squares, where set of all x squared, where x is a natural number, right? But instead of x, I might have put z, I might have put y, I might have put like c, a, b. It doesn't really matter. So it's dummy because it doesn't mean anything outside of the set former, right? It just means that just take, I don't know, like any number. Okay, so sorry. It means that it is a set of all squares of natural numbers, right? You can call that x squared, y squared, z squared, has like makes zero difference. That's what it means. So zero meaning outside of the set former. So if s they are local to the set former. Okay. Let me give you another example. So Q, let's say Q is a set of all A over B, such that A and B belong to Z. So let's make it proper way, and special character. So the way you should do and, you need to use this symbol. Okay, and B is not equal to zero. Okay, perfect. And belongs to Z. Let's also I'll replace it over here with proper characters. But if when you guys type in that on your computer, if you do the handwriting notes, right, you need to always do it this way, the way I'm showing this now. Just on the laptop, it's difficult to do very quickly. Okay. So that's another example of two dummy variables, right, that denote a set of rational numbers. So that set is called a set of Q, is called a set of rational numbers. So it's basically all the natural numbers, all the positive numbers, all the negative numbers, zero, all of them. So okay, so that's the way you should write all the sets in your notes, right? The proper way to do that. So Q equals then the pair of braces, A over B, right? Or you can say like A, then horizontal line B, then the vertical line, like bar, such that A, B belongs to Z, right? And B is not equal to zero. So this set is a set of all rational numbers. Here. Okay. Important note. So a set is a single mathematical object that is intended to group together some numbers of mathematical objects into single whole. Okay. A set should never be confused with its elements, even if the set has only one element. Okay. For example, a set with a 17 in it. So that what I just wrote, right? So two pair of braces and 17 in between is the set. Is the set consistent of the number 17 as its only member, but 17 itself is not a number. One more time. A set is a single mathematical object that is intended to group together some numbers of mathematical objects into a single whole, right? A set should never be confused with its elements, even if the set has only one element. So, for example, 17 in braces is the set consisting of one number, 17, as its only member. But 17, again, in braces by itself is not a number. So it is a number which has only one, sorry, it is a set which has only one number, but it's not a number. It's a set. Whew. Okay, moving on. Let's talk about a couple of properties. So number one, empty set. Juk. Okay, so empty set let's place it this way. For any sets A, B, C, the following is true. Okay. Number one, empty set is always a subset of a set A, well, any kind of A, right? Then A is a subset to itself. Then if A is a subset to B and B is a subset to C, then A is a subset of C, right? Hope it makes sense. So basically, if you have, if kind of, I'm gonna draw that just to make sure that you guys understand this. If, let's say, that's your A and this is your B, right? And let's say B turns out to be a subset of C, like this, then A, the original, that small circle, is a subset of the big circle, which is C. Moving on. If A is a subset of B and B is a subset of A, then what? So if one set is contained within another set, but that set is also contained within the first set, then A is equal to B, right? In that case, these two sets are the same. Oh, that's it? Okay. That's it. Hold on. Yeah, so a couple more things. Let A and B be any sets. Okay. In that case, number one, kind of first thing we can conclude. So if we're talking about intersection, sorry, a union, right? Not intersection, union. Union. So A union B is defined like what? How can we define that using the set formers? So here's how we can do it. It's all X such that X belongs to A or X belongs to B. Okay? So in other words, A union B, what is it? It is a set, okay? And if we define it using the set formula, we can say that it is a set of all X such that X belongs to A or X belongs to B. Okay? Now the opposite. What is intersection using the set formula? How can we define that? Right? I'll use the proper term here, the proper character. Okay, so A intersection B, same thing. It is a set of all X such that X belongs to A and X belongs to B. Okay, what else? A minus B, right? How can we define that? Same thing. It is a set of all X such that X belongs to, what is it? A minus B, right? So A and X does not belong to B. Okay, Again, please use these like symbols when you write in the notes. Okay, and one of the formulas. So where is it? If I do A intersection B, right, that gives us what? It's the same thing as SA minus A minus B. Okay? If you don't believe that, try to draw that, you will see that it's true. Okay? So those are the things which you need to know. That's pretty much it for today. I'll see you guys on Thursday. Please prepare for the quiz. Let me know if you have any questions. See you later. Bye bye.